All right, we're looking at R7, the radical expression. So we're going to be simplifying square roots in this particular section. So I'm going to go through this. This is me making up the video because I failed to record it when we're going through it live. So as I step through these examples, I'm going to kind of explain what we were doing there. So first example, we got the square root of 4. And we've memorized over the years that the square root of 4 is 2. But the reason that it's 2 is because we can break down 4 into with a factor tree into the prime factors of 2 and 2. There's a pair of them. We're doing square roots, so we're looking for pairs. And because there's a pair of 2's, the answer is 2. Similarly, on example B, with the square root of 9, over the years we've memorized that the square root of 9 is 3. The reason it's 3 is because the square root of 9 breaks down into a pair of 3's. So that's why it's 3. When we're dealing with numbers that are not nice square roots, for example C, with the number 12. 12 doesn't have a nice square root. We break it down with a pair of numbers that would multiply to be 12. In our case, it's 6 and 2. 6 times 2 is 12. But 2 doesn't break down any further. It's prime. 6 does, 3 and 2. Because it does that, we then have a pair of 2's. A pair of 2's means a 2 comes outside and a 3 goes to the inside because it doesn't have a buddy. Pairs go on the outside. Things that don't have a pair go on the inside. Okay? So on example D, the number 18, we break that down with 6 times 3. 6 breaks down into 3 and 2. With this one, we have a pair of 3's. So the 3 comes to the outside. The 2 doesn't have a buddy, so he stays on the inside. So it's 3 square root of 2. Okay. Go on to the next one, square root of 54. Don't know much about 54. We know it's even, so we divided it by 2. 54 divided by 2 is 27. So that's where the 2 and the 27 come from. And then we know something about 27. We know it's 3 times 9. So that's where this 9 and 3. Well, 9 breaks down into 3 and 3, and it gives us a pair of 3's. We have a 3 on the outside that comes from this pair of 3's. The 2 and the 3 that are left over are this 2 and the 3 that are underneath the radical. They don't have a buddy, so they have to go inside. When anytime there's more than one thing on the inside, we multiply them back together. 3 times 2 is 6. 3 square root of 6. That's what square root of 54 breaks down to be. Example F, we have the square root of 72. We didn't know something about 72. Remember, that was 9 times 8 when we learned our multiplication tables as a kid. So 9 times 8 is here. We break down the 9. There's a pair of 3's. We break down the 8 to be 4 times 2. And then 4 breaks down further to be 2 times 2. We want to break those numbers down until they're prime numbers at the end. Okay, so 3 times 3, that's this 3. This right here is this 3 here. 2, this is this 2. This 2 is that 2 right there. Okay, the 2 that's left over is on the inside. Then we multiply the 3 and the 2 on the outside to get 6. So it's 6 square root of 2. Okay. Right. Next example, square root of 132. So just picking some bigger numbers there to work with. We don't know much about 132. We knew it was 2 goes into it because it was even. So we divided 132 by 2 and got 66. So that's where these two numbers at the front come from. And then 2's prime, so it's done. 66, 6 and 11 go into that. And then 6 breaks down to 2 times 3. We have a pair of 2's. That's the 2 on the outside. And then we have 3 and 11 left on the inside. Remember, we're going to multiply anything left over on the, then there's more than one thing on the inside or the outside. We multiply them together. 3 times 11 is 33. So we end up the square root of 132 is 2 square root of 33. Okay. On example H, we used the number 84. So 84, we used 4 goes into it. 4 goes into 8 twice. 4 goes into 4 once. So that's 4 times 21. And then we break down those numbers. 4 breaks down into 2 times 2. 21 is 7 and 3. We have a pair of 2s. So that's the 2 that's on the outside. 7 times 3 is 21 on the inside. Okay. Next skill we want to talk about is multiplying radicals. And the rule for multiplying radicals is you're going to say inside times inside, outside times outside. That's the rule. So you also want to simplify last. Don't simplify first when you're multiplying radicals unless there are negatives inside. We'll talk about that in the complex number section. Okay, so here we have the square root of 5 times the square root of 45. So we're going to multiply those two numbers together. 5 times 45. That's what I'm showing here in this first step. 45 times 5 is 225. And then we're going to break that number down and simplify the radical. So when I'm simplifying the square root of 225, I got it from 45 times 5. So I'm going to use that for my first factor tree. And then 45 is 9 times 5, and 9 is 3 times 3. So I have a pair of 3s and a pair of 5s, and I don't have anything that's left over. So I only have outsides here. I have 5 times 3 on the outside and no radical left over because there wasn't anything left over in my factor tree. So that 5 times 3 is 15. The square root of 225 is 15. Example J, similar problem. We got an outside parts, 3 times 4, that's the 12 that's here. 6 times 8 is 48. That's the 48 under here in the blue. Okay, and then we would break down the 48. 48 we know is 6 times 8. 6 times 8. 6 breaks down into 3 times 2. 8 breaks down into 2 times 4. And then 4 breaks down into 2 times 2. I have a pair of 2s and another pair of 2s. So I have the 12 that was originally out here. That's this 12 right here. Then I have 2 2s, one for each pair of 2s. So I multiply 12 times 2 is 48. And then I have the 3 that didn't have a buddy that had to stay on the inside. So 48 radical 3 is what we have for the multiplication of 3 radical 6 times 4 radical 8. All right. Let's talk about adding and subtracting. Adding and subtracting is just putting like terms together. And for two terms to be like terms when you're dealing with radicals, they have to have the same square root involved. Okay, so we have 3 radical 2 and 6 radical 2. So we want to take those and put those together because they're like terms. They both have radical 2's. 3 plus 6 is 9. The radical 2 stays the same. And then we have the plus 5 radical 3 that wasn't a like term, but it was part of the problem that's still left over there that we leave. Okay? Sometimes they disguise the like terms for us, and we have 2 radical 12 plus 5 radical 27. At the beginning, in the black here, they are not the same. They don't have the same radical. So we've got to simplify them. If there's any simplification that can happen, we need to do that. So we break down 12, 6 times 2. 6 breaks down to 3 and 2. We have a pair of 2's. So this 2 comes out to this 2 and multiplies to get 4. Then we have the 3 that's left over on the inside. And then here we have the square root of 27. We break that down to 9 times 3. 9 breaks down into 3 times 3. So there's a pair of 3's. 3 times 5 is this 15. And then we have the 3 left over. Now they are like terms. They both have radical 3's. And we're adding them together. So 4 plus 15 is 19. And then radical 3. And we've got the like terms put together. Okay, so we had to simplify first on addition and subtraction. Okay. If there's a fraction involved with the radicals, the square roots, you will want to split that apart and put, we have a square root of 11 over 169. So we split it into the square root of 11 over the square root of 169 and then try to simplify each of them separately. So we would simplify the numerator, get the square root of 11. Turns out it doesn't simplify here. And then square root of 169 happens to be 13. And so we end up with the square root of 11 over the square root of 13. So we get a fraction there. Okay. If you had maybe the square root of a fraction, maybe you had square root of 24 over 25, something like that. Split it apart, square root of 24 on top, square root of 25 on the bottom. 5 and 5, we get a square root of 5, or 25 is 5. That's on the denominator. The numerator is a little more difficult. We need to break down 24. I'm going to use 8 and 3, 4 and 2, 2 and 2. So there's a pair of 2's. That's 2. And then there's 2 and 3 left over, which is 6. So it's 2 radical 6 over 5, and we've simplified that fraction. So split it apart, simplify each of the numerator and the denominator separately, and that will be your simplifying of square roots in fraction style.